focused on examples 1 and 3. And what you were supposed to do was look at those vertices and use the objective function to try to find the min or the max based on those vertices. So plugging them in number 1, we can see that the max occurs at the point 4, 2. And in number 3, the min occurs at the point 6, 8. And again, we can find the min and maxes by plugging in the corners of the vertices and finding the largest value. So in example number 5, you were graphing the line x plus y greater than or equal to 8. You were graphing the line y greater than or equal to 5 and the line x greater than or equal to 0. So a y line is horizontal, the x line is up and down, and then the x plus y gives you the line that is diagonal. In doing so, we see that we have 2 vertices. So those 2 vertices would act as my minimum. It doesn't ask me for a maximum because this graph is increasing infinitely both in the y and x direction. Therefore, we can't really find a maximum. But we can, however, find a minimum, and we saw that the minimum occurred at 0, 8. So the minimum occurred at 0, 8, or 16. Okay, and number 7, once again, we're going to graph our 3 constraint equations. And then we're going to identify our vertices. And then we're going to plug each of those vertices into our objective function and find the minimum for that objective function. So in this case, it is 8, negative 2, or 8 plus negative 6, which is 2. So our minimum value at 8, negative 2 is 2. In our next example, we now have beginning and end domains for x and y. So it begins at 2 and ends at 6. It begins at 1 and ends at 5. So we now have 4 lines of constraint. And then we graph our linear equation, which is the diagonal. And this time, I notice that I have 5 vertices. And I need to find the maximum. And the maximum occurs at 6, 2. All right, so number 10, we're going to skip because that was for the other group. I'm just leaving it there for 1 second so they could pause and see. Or if you need some extra review tonight, you could use this as a pause and see. And I guess even over the weekend. Okay, looking at number 11. Number 11 says trees in an urban area help keep air fresh by absorbing carbon dioxide. A city has $2,100 to spend on planting spruce and maple trees.
The land available for planting is 45,000 square feet. How many of each tree should the city plan to maximize carbon dioxide absorption? So first we need to take into account the number of spruce and the number of maple. Then we need to take into account how much money we have. So a spruce is 30 and a maple is 40. So it'd be 30x plus 40y less than or equal to the 21,000 we have to spend. And then the next thing is we have 4,500 square feet, or 45,000, sorry. So then square feet per spruce plus square feet per maple has to be less than or equal to 45,000. So that is your two red lines. So we're going to graph both of those red lines. We would technically have a domain constraint at 0 because, again, we know that we can't graph negative numbers of trees. So the x and y axis also act as domains. That's why I didn't shade below them. That would give me a vertice at the y-intercept, at the point of intersection, and at the x-intercept. So I have 3 vertices plus 0, 0. Well, we know we're not going to plant 0 trees, but it would act as a vertice as I was just explaining the domain constraints. And then what we're going to do is plug those in to the pounds per year, because the question says how many of each tree should the city plant to maximize carbon dioxide. So whatever you're maximizing or minimizing is your objective function. So it's 650x plus 300y. So the carbon dioxide gets maximized after we take into account the cost and the square footage. Good? Questions on that? Anything that you didn't maybe understand, or you don't know why I did what I did? Okay, 13, a biologist is developing 2 new strains of bacteria. Each sample of type 1 produces 4 new viable bacteria, and each sample of type 2 produces 3 viable bacteria. Although at least 240 new viable bacteria must be produced, at least 30, but no more than 60, can come from type 1, and not more than 70 can come from type 2. Sample 1 costs 5 and sample 2 costs 7. How many samples of type 2 should be used to minimize the cost? So we put 70 for type 2 because we cannot have more than 70. We need 30 to 60, which are these 2 lines for type 1. And then our cost function is going to use the 5x and the 7y. And we have one other function, which is the 240. So that's where the 4x and the 3y come in. So you have 4x plus 3y greater than or equal to 240. Giving you 4 vertices, which are identified in the table here. Finding their cost, we see that the minimum cost occurs at 60.0. Which would make sense because type 2 costs more than type 1. Okay, 15. Your pizza shop makes $1.50 on each small and $2.15 on each large pizza. So that $1.50 and $2.15 is our profit or revenue. On a typical Friday, they sell between 70 and 90 small pizzas. So that's what's graphed right here, 70 and 90. They sell between 100 and 140 large pizzas, so graphed over here. The shop can make no more than 210 pizzas in a day. So that is where small plus large has to be less than or equal to 210. How many of each size of pizza should be sold? So what you have to do is find your vertice intersection points. And then what we're going to do is plug in those points to our profit function. And then we're going to find our profits at each of those points. So you would take 1.5 times 70 plus 2.15 times 140, and you get 406. Similar but different, you take the 1.5 times 70, but now 2.5 times 100. So we know we're going to make less money selling fewer large and the same number of small. Now we sell more small, but the same number of large. And we get 350. And then last but not least, we sell the same number of small and more large, and we get 436. So your answer should be, 70 or 90 small and 140 large. Okay, there are 20 true, false, and 20 multiple choice questions on a test. A correct answer to a true, false question earns 10 points. A correct answer to a multiple choice question earns 12 points. The test makers determined that if it takes on average 3 minutes to answer true, false, and 4 minutes to answer a multiple choice, students have 1 hour. Hold on, guys, I'm sorry.